Oke, Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Zainal Abidin. My name is 137. Uh, today I will presentation about the gyroscope with my team. Okay, this is next. Okay, this is my team. My team is consists of Avatar, Fadli, and Roby. With the name is in the screen. Okay. The next one. Okay, the first time uh I will say the okay, we will talk about the definition of the gyroscope. Okay, what is gyroscope? So, gyroscope is a device that, depending on its composition, and can fulfill two functions to provide information about the variation of the orientation of a system with respect to a reference axis, or to provide information about the rate at which the orientation of the system varies when it is rotating, that is, its angular velocity. So, the next time we will talk about principle and the mechanism, uh, and of course the application of the gyroscope.
Hello, my name is Alfarizi. I'm going to present about the working principle of gyroscope. Consider non-spinning gyroscope. The torque due to gravitational force will cause the gyroscope to rotate about the x-axis. To make the gyroscope move upward, we need another angular momentum. This angular momentum can be obtained from the spinning gyroscope, since angular momentum is formulated as the dot product of inertia and angular velocity squared. Due to gravitational force acting in the center of gravity, there will be a torque perpendicular to the angular momentum vector. By using the right-hand rule, it can be observed that there will be torque in the x directions. Since the angular momentum direction follows the torque directions, the angular momentum caused by this torque directions will be in the x-axis. This is the calculations of the precession angular velocity. Assuming the angular velocity of the gyroscope is much greater than the angular velocity of precessions, the angular momentum working about the z-axis due to precession angular velocity can be neglected. Therefore, there are two angular momentums in total. Some of those angular momentums will change the directions of the gyroscope, and eventually the gyroscope will move upward. Due to an external force contributing to the change of angular momentum, the angle within the system is conserved. Therefore, as the spinning gyroscope comes closer to the z-axis, the precession angular velocity will also increase to overcome the change of angular momentum of the torque.
And this is the example of demonstration of the gyroscope.
Velocity. So let's take a look at this. It will appear as if the gyroscope defies gravity. Let's try it. And what I need here, first I need to get it spinning. That's what this almost looks like a shoe polisher will accomplish. And let's see there. I want to make sure I got this in the right direction. Makes a little bit of noise, so hang in there with me. All right, so we got that spinning. And there we have it. There's a gyroscope in action. So what's happening now is, because of this very fast spinning motion, if you follow the right-hand rule, if you turn your fingers in the direction of the spinning disc and it's spinning in this direction, there will be an angular momentum vector pointing out this way. By placing it on the stand, there's a torque that causes it to push. The torque causes the gyroscope to be pushed in this direction, which causes that change in the angular momentum. As you will see over time, the gyroscope will rotate faster and faster and faster because the torque causes an acceleration in this particular direction. So you can see that as time goes by, the gyroscope will just spin faster and faster and faster, and will also begin to orient at a greater and greater angle relative to the horizontal. This is just quite amazing. If you imagine here that the weight of the gyroscope should be pushing this down, it's only being supported by this central point right here on this stand. And as you can see, that it's beginning to spin faster and faster and faster as the angular momentum is changing, and also to begin to orient itself at a steeper and steeper angle. So that second, the rise of the gyroscope is caused by, again, if you follow your right hand rule, if you turn your fingers in the direction of the spinning gyroscope, you can see that the angular momentum is in this direction.
Avatar 113, and I'll explain about gyro compass, the application of gyroscope. I'll start with the disadvantage and advantage. Firstly, the advantage of gyro compass is it doesn't need magnet to locate the North Pole, but it cannot seek the North Pole. We need to tell him first where's the North Pole. That means it has a long calibration time, and also because it's a mechanical system, it's hard to manufacture and it's also expensive. Look at this disadvantage. Why are people still using it? Well, because it doesn't need electricity. I mean magnet. So when we put it on a metal ship or metal plane, the magnetic field, because it doesn't need magnetic field, where metal is a magnetic field, the compass is still accurate. Okay, so how does it work? Firstly, the spin axis will be made horizontally. Because of that, we will know where's the north. So if this is spin, north is automatically here, and it won't change because of angular momentum. Okay, next, what we need to do is we need to adjust where is the tangential. How to do that? We will use mass, gravity, to achieve equilibrium. Why do we need to do it? Because we need to make sure the red one always points to the east and blue always points to the west. That means, well, it needs to be tangential.
My name is Roby Sitepu. My student is 142. I will talk about the application of gyroscope in our real life. That I will talk about gyroscopic instruments on aircraft. That will be divided into three components. There is altitude indicator, and then heading indicator, and the last one is turn indicator. Both of them are driven with two kinds of gyroscope. There is air-driven gyroscope, and the next one is electric gyroscope. Mostly air-driven gyroscope will drive the altitude indicator and heading indicator, and electric gyroscope will rotate the turn indicator. Air-driven gyroscope is worked by sucking the air from the outside with the vacuum pump pressure from the device. The gyroscopic instruments will control about 4 axes of the aircraft. That is the pitch, the bank, yaw, and heading. First, we talk about altitude indicator. That's the gyroscope rotates from the air that flow in the device from the vacuum pump pressure. And this is the gyroscope that rotates around the vertical axis. It controls the pitch axis. Next one is heading indicator. Indicator is there is a knob to adjust. That's from the right upper picture, and the gyroscope rotates around the horizontal axis. It controls the yaw or heading. And the last one is turn indicator. The gyroscope rotates from the electric motor, and the function of it is to know the coordinates of turn that rotates around the horizontal axis. Okay, thank you.
Okay. Thank you very much. This is our presentation. Then we took reference from YouTube for the video and also from article. Then this is our team contribution. Okay. Thank you very much and wassalamualaikum warahmatullahi wabarakatuh.